So this is the 2015 Leave Insert Ordinary Level Paper 1, and we're looking at question number 6. Part A, the complex number z1 equals a plus bi, where I squared is equal to -1, is shown on the Argand diagram below. Okay, so we've got z1 here, and here it is down here. Part 1 says write down the value of a and the value of b. So, z1, the complex number here, is equal to, from the origin we go over 3 on the real axis plus 1 on the I-axis. So that's 3 plus 1i, that's the complex number z1. So the a part, the real part, is 3, and the b part is 1. Part 2 says the image of z1 under reflection in the real axis is z2 equals c plus di. Write down the value of c and the value of d. Okay, so the image of z under reflection in the real axis. Well, the real axis is this axis here. So if we reflect it in that axis, it means we go down 1, 2 steps and reflect it out the other side. 1, 2. So that's going to be our z2. z2. And that is equal to 3 minus 1i. So z2, the c value is 3, and the d value is -1. Okay, so part B1 says the angle theta is formed by joining z1 to 0 plus 0i to z2. Find the cos of this angle theta correct to 1 decimal place. Okay, so let's try and visualize the angle we're talking about. So from z1 back to 0 plus 0i, or the origin, and then back to z2. So that is the angle we are actually looking for, this angle here in blue. And we're trying to find the cos of that angle. Okay, well, what we could do first is we could find this angle here in red, in other words half of the angle we're looking for. We could find this angle here first by looking at this right angle triangle. So in this right angle triangle, if we call that red angle there x, so let's say that angle there is x, well, we can say we know that the opposite, we know the side opposite the angle is 1, and we know the side adjacent to the angle is 3. So we can say that when we have the opposite and the adjacent, that's tan, we can say that the tan of the angle x is 1 over 3. So if the tan of the angle x is 1 over 3, well then the angle x is the inverse tan of 1 over 3. And the inverse tan of 1 over 3 is 18.4349 and so on degrees. Okay, so that's the angle x. So the angle that we were looking for, the angle in blue, the big angle here in blue, which we can call that angle in blue, call that angle there in blue theta. Well, theta would be equal to double this, so that'll be 2 times 18.4349 and so on, which is equal to 36.87 to 2 decimal places. So that's the angle theta. And then we are actually asked to find the cos of this angle theta. So the cos of 36.87, that gives us, to one decimal place, well, let's just see, first of all, the cos of that angle is 0.7999, it goes on like that. But to one decimal place, that is 0.8. So that's our answer over here. The cos of theta is 0.8 to one decimal place, 1 dp. Okay, that's the end of part B1. Okay, finally B2 says show that the modulus of Z1 multiplied by the modulus of Z2 is equal to the cos of, multiplied by the cos of theta is equal to AC plus BD, where A, B, C, and D are the values from part A. So we have to show that this equation is true. This identity is true, really. Okay, so the modulus of Z1. So if we go back here, we can see the modulus of Z1 will be the distance from the origin to Z1. And if we know that Z1 is 3 plus 1i, if Z1 is 3 plus 1i, well then the modulus of Z1 by Pythagoras will be the square root of 3 squared plus 1 squared, and that's just equal to root 10. Okay, well Z2 is 3 minus 1i, so the modulus of Z2, which is what we're doing next, will be the square root of 3 squared plus minus 1 all squared this time. But again, that works out to be root 10. So we have Z1 is root 10. We have Z2, the modulus of Z2, sorry, is root 10. The modulus of Z1 is root 10. Cos theta is 0.8 from the previous part. So we can set up the left side of this equation then is root 10 multiplied by root 10 multiplied by 0.8. And we're trying to show that that is equal to AC. So if we go back and check what they are, A was 3, C was 3, so AC is A times C, so 3 by 3 plus BD plus B, if we go back, was 1 and D was minus 1. So that's plus 1 times minus 1. So we're trying to show that this is true. Let's work this out. Root 10 by root 10, well that's 10. So it's 10 times 0.8. Is that equal to 9? 3 threes is 9. And 1 multiplied by minus 1, that's minus 1. So it's 9 plus minus 1, which is 9 minus 1. And 10 by 0.8, that's 8. And 9 minus 1 is 8. So there we've shown that the modulus of Z1 by the modulus of Z2 by the cosine of the angle theta is equal to AC plus BD. And that's the end of the question.